All right, well, welcome back from lunch. Our talk today is going to be on best practices. This is a returning presentation with some new twist to it from what Glenn was telling me. So with that, I'll turn it over to Glenn, and I'll be back for Q&A at the end.
Good afternoon, everyone. I've got a number of topics that I'd like to cover off today, and I'd like to start out with just saying that don't take these as absolute gospel, because in every individual situation, your circumstances may vary. So in general, I think these are best practices, but circumstances can vary. So these are the topics that I hope to cover off, starting with procedures, and that's about getting it right. Now, on the right-hand side, I just give you some idea of what we do for procedures. And if you attended the Toyota presentation that occurred in this room just before lunchtime, procedures are a big deal. And this is not something that we took out of a book. This is something that we learned over the years, that as you do things, you're going to have to do procedurally better and better to avoid this technical debt, bug problems, or making sure that everybody's system runs well. Because as I said this morning, getting it right is important. What we do is critically important. Downtime is not acceptable. All that stuff we know. So that's just an example of one flow chart we have in our procedures. So technical debt is a term that is used in the industry that means that by cutting corners up front, you create this debt, something that you have to repay in the future because you didn't do it quite right the first time, or didn't take enough care, didn't get the specification right, or took the shortcut. So that's what we try to avoid, getting this technical debt, because unlike if you're going on a vacation, you decided that you didn't book your Disney tickets right, okay, that affects just that vacation. If you're going on a production line, you didn't do it right, that's going to affect production for years to come. And you know that. Plan ahead. Nobody likes to do this, but this is what it means. You got to plan ahead. So, document. So one of the things that we find is a really good practice is to take the documents that you have, whether they're line diagrams, PLC programs, design documents, any other forms that you have, you can copy them into the VTScada directory and import them into our repository. That does two things. That gives you a history of all the changes to your PLC program and your diagrams, and they're distributed across all your computers. So if you want to get them off any machine, you got redundancy backup automatically built into the system. So I think that's a great practice to use in the system. There's this flag on I/O tags. It's called questionable. Now, questionable is something that I think is often underused, but it's a great way to commission your system. So tags are generally created with this questionable status checked, which means that it shows up with a question mark on your screen. You probably know this, but when you're going through your system, if you see a question mark on that tag, you can just right-click on it and say it's not questionable anymore. But it's there to remind you that you should have checked out that I/O tag to say that it is actually working. Did you check it end to end? Are you confident that it's working? And when you're confident that it's working, there's a visual indication that you take that question mark off the system. And not only is that question mark off the system, it records who was logged in that took it off questionable and when that was and on which workstation that happened. So you get an audit trail of all those things that happen. And in many industries, that's important to know who did it when and why. And we have this capability in the system called auto deploy. Now, the idea that when you make a change on one computer in VTScada, configuration change or questionable status, we have this idea that when you make the change, you have the choice as a configuration setting of making that change automatically distribute to all the other computers on the network, or you accumulate them and you hit a deploy button when you're satisfied. So there are two modes of running, and you've got to make your decision on how you want to run your system. We shift the system with auto deploy on, because what we've found is that operators, users, configurers, engineers forget that there's this deploy button. So they get it configured, they work on their one computer, and it all works because they see everything working. That's the intent. You get it all working on your one computer. And then they think they're done. They forgot to deploy it. And if you don't deploy it, it doesn't go anywhere. So we have this two modes of operation where you build, get everything right, then deploy it, or you go into auto-deploy mode where I'm going to make the changes and send them out as they're made instantaneously. So if you're in the, I would generally suggest that if you're in a big development mode, don't go into auto-deploy. Go into build, test, then deploy. Now, all the changes that you've made are automatically tracked on the machine that you made them, and the deploy action is also tracked on every system that is receiving the changes. And even if your machine was down at the time that the changes were deployed, you will still receive them when you come back online. And we've got some fun examples where you can be on an airplane, make some changes. You can deploy them on the airplane, even though you're not connected to the internet. When you plug back into the plant, they will go out. That's just a really neat feature of VTScada. And these are kind of a little bit of system of random things associated with procedures and policies. I think you need to figure out what you're going to do with upgrades. There are two extremes, I would say. Some that get the system working and they will not upgrade once they've validated the system for years. And the others is that every 2 weeks we do a build cycle. 2 weeks we do incremental builds so that we have minor changes every 2 weeks, and it's up to you to grab those changes or not. You got to figure out, do you want to upgrade every 2 weeks or do you want to upgrade every 5 years? Most likely somewhere in the middle. Some people feel like, there's more bugs in VTScada. We've got to update again. We've got to update again. That's not the point. We're just doing incremental changes, so there's small changes over time. So you've got to figure out typically 3-6 months upgrade cycle, or when you see something in the changes that we send out, the change notification, you see something that is interesting to you, you plan to say, I'm going to roll that one out next Tuesday, or something of that sort. Because so often upgrades, even though you don't have to take your system down, you can upgrade one machine at a time. It can be time consuming. This one's a little bit foreign to many of us, reviewing each other's work. It sounds funny, but 20 years ago we had the policy of a non-policy. We just write code and we deliver it. We found that by having somebody review the code, the number of bugs that went out was cut in half, like that day. So reviewing someone's code or what the changes they've made or their drawings or their PLC code or whatever is absolutely fundamental to getting better quality. I don't mind when someone finds a problem with my code. If I write a code and I deliver it and somebody finds a problem, I'm happy that they found that before it went out into a customer's hand. So I don't feel bad about it. You don't feel bad that you get into a culture of that's just the way we work. We understand that we are here to get rid of problems in the system before they get into production. And we've got this third level now. It's not just looking at functional review, we have security review as well. And that may be a little bit too much to bite off at one time, because security review is a whole mindset of how you're looking at this particular change to see how it might be used by some bad actor to infiltrate your system. So getting it right. This is our actual flow chart, if you can believe it, of how we deal with a new feature. I don't expect you to memorize that, but the point is it's big and complicated, and not because we sat down and did this in one day. This is a 20-year evolution. So this is what it can evolve into. If you're doing a project, you probably don't have to do this level of complexity, but I just say, when you think about it, you will get better at it. So don't worry about trying to copy that. That's not what the whole message is. It's saying, if you do a little simple test of looking at somebody else's code, writing down what the requirements are, Just simple things like that. Again, the Toyota procedure was mirroring this quite well. So, don't want to scare you. I just want to say, it's a business. We're in the business of getting it right. You cannot afford to have a disruption. Plant downtime is one thing. Pumping contaminated water into a city water supply is a whole different matter. Having a major oil spill, losing control of a ship, all really bad things. And all these things have happened. Like some of the things we learned from NASA, they test for many years sometimes, and the Mars polar lander crashed into the surface because of a software bug. And you think, how could they let that happen? Well, if you looked at the code, and I've seen it, it's like, yeah, I see what they did wrong. Why didn't they see what went wrong? But I had the benefit of somebody highlighted, this is the piece of code that was wrong. And it's probably millions of lines of code. Avoiding technical debt. So let's go look at some tags. Tags are the fundamental pieces of the code. So we start with tags is often the way you start with a system. Once you figure out how you're going to plan to do the system, think about your tags. We have this get a naming standard for your tags. It seems fundamental, and often people just will name the tags as they create them. And over time, people will change their standards, but rather than having a hodgepodge of somebody creating this thing called P1, somebody else will call it Pump 1, and someone calls it Sump 22, you need to have a way to have some sort of consistency so that when you're maintaining the system in the future, drawing using those tags, everybody understands what these tags mean, how they're organized. It makes a huge difference in your overall maintainability of the system. So there's a parameter in your I/O tags called equipment type. You may not be familiar with it, but it's a really good tool for getting your handle on organizing your system. So the equipment type is just a parameter. It's a free-form parameter. There are only a couple of predefined ones, but you can have an equipment type called pump. It could also be tank. It could be, airflow, or a whole pH meters, acidity, all different kinds of equipment that you're measuring. If you categorize them all, it makes it very easy in our tag browser to say, show me all the pH meters in this area. It makes it a whole lot easier. Don't have to rely strictly on the names. You've categorized your equipment by type. So it's a really good tip, I would say, of getting it easier to maintain your system. And use context tags or drivers to organize your tags into a hierarchical tree of tags. So we not just have a flat list of tag names, which was the old style, that made naming quite challenging. For many years now, VTScada has had this ability to define tags in a hierarchy. So you can have a driver. Underneath the driver, you can have I/O tags. You can have alarms, or you can have a context which just represents a piece of equipment or an area of the facility. And often these hierarchies can be multi-layer. You've got to think about that organization. If you get it right, your life is good. Good news, if you get it wrong, you can change it. So one of the good things about VTScada is that, unlike about every other package out there, you can change the name of a tag without having to rework any of your history, any of your alarms, any of your pages. They'll all still connect to where they are. The name will just change across all the system. Same thing if you actually move a tag from one area to another, no problem, you don't lose any configuration. So you can reorganize your tag structure without having to rebuild your pages, your alarms, or lose any history. So it's a really helpful way. So it's a safety net to say, after I've done it all, and this happens a lot, I wish I had done it this way. Or I've gone into facilities where they say, we learned over the years that we have a new tag naming scheme, but the old tag naming scheme is there. So half our systems in this style, half the systems in that style. You can just dump everything out into an Excel spreadsheet and change all the names, and everything works in VTScada. You don't lose anything. In the same sort of vein, we've got tag start conditions. Now, many of you probably know this, but there is a way to control when a particular tag starts. And sometimes you say, I only want to run this tag. For instance, I have a generic pumping station. I've built a template. And one of the parameters of that template is how many pumps are in the station. So when I pump one's there, if there's one or more pumps, two or more pumps, and say, well, there's only 2 pumps, so pump 3 only comes on, or that tag only starts if number of tags is 3 or more. So it makes your life easier to manage the system. And you can take it a bit further. You say, you know, I want a VTScada system over here, and I don't want to run everything because that just drives up my tag count. I've got my system organized into a context or into a tree. I don't have to go to every individual tag in the system. I can say, the reclaim system. I can put a tag start condition on it that says that if I'm not running on that computer, run it. Otherwise, don't run that whole subtree. One condition can shut down a whole series of tags, making your application smaller and lighter. That configuration is available to everyone. You don't have to have a special configuration for that machine. It's managed centrally still. So these tag start conditions are very powerful for managing larger systems. I would think that there is a gotcha on that too. Tag start conditions take a little while to calculate, so they can actually slow down your startup time if you have a lot of calculations going on. But generally, you have a small number of subsections that you're going to start. It's when you get tens of thousands of calculations running at startup that you could slow your system down. One of the things that's often taught in the course is, and I will contradict that a little bit, is that you put the port tag on top, and underneath the port you put the driver tag as a subordinate or child tag. Under that you put your I/O tags. Well, I would suggest that tends to make your tag names really long, because the tag names are the parent name, the port name, the I/O name, and so on. You get these longer tag names, and they can cause you a little grief when you're trying to put them into a report or something like that. So just as a convenience, or just a way to help mitigate that, put the port tag as a sibling or parallel tag to instead of on top of the driver tag. Doesn't really take any difference in the performance or organization, really. It's still pretty obvious what's going on. This one, if you haven't learned it yet, you should do. Tag type templates are very powerful. And we've taken the model of using, I would call design by example. So you build something that works, and then you can template it. You don't have to build the template and then create an instance of it. You just build something that works on one piece of equipment that's going to be similar to others. You just build it and you find out, yeah, this is going to be useful, I'm going to use it again. You just create a template from that. And then you make another instance of it. And then you keep making more and more instances of that. So when you do have an instance of these tag templates, you can just create it, one tag, and all the other tags that come along with that are just instantly created, which is great. And now you say, well, what if I got it wrong first time? Which you probably will. You probably get your template wrong first time, but you can go back and change the template, and then all the other instances that you created from the template will automatically update. So you don't have to worry about getting it perfect first time. And you say, yeah, they're all pretty close together, similar, but this one has got a rain gauge over here, and the scaling is different on that one over there. We have this idea that you can go into any individual instance from a template and override specifically any parameter on any tag in that template, and that will be maintained when even though the template may be consistent, you can actually have customization, even adding new tags to a specific instance of that template without breaking anything. So, very powerful feature, take advantage of it. It makes your build time incredibly powerful. It makes it easy to get it right across many systems. Like almost every system you get involved with, there are common pieces of equipment which are just repeated over and over and over again. And if you've got a PLC program, that's what we do as engineers and programmers, we like things that are the same every time, if we can get away with it. This helps you build the same thing and just repeat it really quickly and easily. And to make your context tags easier, one of the ways you can manage the context tags is to go take a particular instance and say, update all my instances to match this one. The problem is that sometimes every instance you have has some special something about it that you don't want to push out to everything else. So what we do is we suggest that you actually create a separate part or a separate template context within your application that you never really run. It's just a place to hold all your tag templates so that you manage them. And one of the tips we learned from one of our oil and gas customers was, you can disable that context tree so it doesn't even show up unless you really want to see those templates and manage them. So they kind of get hidden. Moving on, alarms. Now we got the tags in. Alarms are really what it's all about. When it comes right down to it, we're not flying the aircraft anymore. We're not sitting there with our hands on the wheel, driving this plant 24/7. Our plants are really self-operating for the most part. There are a few industries where you actually have an operator there 24/7, but they're not actually controlling things in general. They're there to watch and react quickly if something happens. So the alarms are the thing that tells you something has happened, you have to watch for it, or you have to deal with it. So alarms are probably the most critical thing in your system. If you get your alarms right, your life is good. You don't want it to tell you too late, you don't want to get overloaded. And one of the things you have to get the right information out. If you've got a large system, the description of the tag is what describes the alarm. So make sure you get your descriptions meaningful to those that are getting the alarms. One of the things that studies have shown is that operators can only absorb about 200 alarms per day, and then they go numb. They don't respond very well anymore. They just get into the They get into the Homer Simpson mode of little bird pushing the acknowledge button over and over again. So you got to keep the number of meaningful alarms down to something like that, or you need to split your load into different operators. So the game in the alarms business is to limit the alarms you have to those that are meaningful. So part of that is setting priorities correctly on your alarms. If you make every alarm critical, they're going to get numb. So you really need to organize your alarms. And we have a diagram, but we haven't put out in our manual, I don't think. But there's this concept of there's two things which affect your alarm priority. One is the time someone has to react to that alarm. So you say, well, I've got seconds to react to this alarm. There's a chlorine leak, there's a fire, you have seconds to react. You have something else that's, the tank is filling up, I've got minutes or hours to react. And then you say, the bearings are getting worn on this, so the air filter needs to be changed. This is a long time to react. And then you've got the criticality. What happens if you don't deal with that? Well, there's a little vibration in that pump. I don't have to deal with it in minutes. But if I don't deal with it soon enough, I'm going to lose that pump. I'm going to be out of production. So you've got this criticality of saying, well, my sensor's off by 5%. What does that mean to production? Maybe nothing so much. Maybe it's absolutely critical because it's a billing thing. So you've got it organized by response time, and another axis is going to be what's the consequence of not dealing with this chlorine leak, or this fire, or this dirty air filter. And you take a look at that, and in that grid you can put in critical, medium, low priority. And that's where you kind of look at things that you got little reaction time and the consequences of not dealing with it are just dire, health and safety, or critical production loss. Like if I'm going to shut in the oil well if I don't respond in 60 seconds. That's, bad news. Huge production losses. or saying, yeah, I'm going to have to clean that filter. So getting your priorities right so that the operator, when they see things on the screen, and there's a bunch of alarms coming in an alarm storm, they want the critical ones at the top. And those critical ones are the ones that really have high consequences, low reaction time. That's what they need to deal with. That's how you get rid of some of those 200 alarms a day. You make sure that they focus on the right things when there's lots of things happening. So the process is out of whack for some reason, and lots of things start going wrong. Focus on the critical stuff. So getting that right is really the key to making your life better, or the operator's lives better. We have this other thing that's fairly new in the product is called alarm suppression, or suppress by design. And this idea, as I mentioned earlier, is you say, I have something like a flow rate. I want a low flow alarm. Well, a low flow alarm when the pump is off is kind of silly. You're getting redundant alarms. Or I've taken a piece of equipment out of service. I see this a lot in facilities where there are alarms going off. I'll say, the operators know that. They're working on that piece of equipment. I'm going to get alarms. Fine, that's not right. You don't want them to be disturbed with things. They're going to get numb to those things. They're going to ignore those things, and ignoring alarms is not a good thing. Suppress the alarms so they don't even see them, so they don't even know that there's going on. They can see that the equipment is shelved or out of service, but they don't need to be distracted by alarms going off in the background. Shelving is that other thing that allows you to take an alarm and put it out of service for a period of time. Typically it might be an hour, it might be days, it might even be months. But there's a time limit associated with it so that you can say that I can shelve this, but I'm not going to forget to take it out of service, but it's going to come back alive at some point in time in the future. If I shelve it versus disabling it, because you find situations where people disable the alarm because they're working on it and they forget to turn it back on again, and then you have no alarms. That's not the thing to do. Shelving solves that problem. And if the system is ready sooner, you can unshelve it, but if you forget, the timeout kicks in and you're back online. They're not done with it yet, I'm getting alarms, so I can shelve it a little longer. We have this other tool in VTScada called the bad actors. And some jokes about who's a bad actor, but the idea in the alarm world is that there are alarms that are going off all the time. And sometimes they're not so easy to see when you're getting 100 alarms a day, which ones are the problem ones that keep recurring. People don't notice them anymore, but they're creating this background noise of people. It goes off every day, I don't know why. So you get this bad actor. There's a tool in VTScada. You go on the alarm page, you can pull up bad actors. It'll show you the alarms that have occurred the most often in any given period of time. By knowing that, you can say, I was in the city of Sacramento, say, you're seeing this alarm goes off like twice as much as any other alarm in the system. Why? Oh yeah, they've got a bad sensor on there. I say, okay. That's causing your operators a little bit of a distraction. They're taking their attention away from something that really might be going wrong. So knowing where the problems are, you can go fix those problems. You go in and say, that sensor needs to be replaced, or whatever needs to happen to make that bad actor go away. The set point may be just wrong for it. Okay, going down to the next level. You've got your tags, you got your alarms, now you want to visualize this. And I say some of that is a little less important than the alarms, but still you want to be able to visualize your system. You can go look at your system in the tag browser, but that's really not the best way to look at your system. So the first thing I would say is you organize your system into a hierarchy, and this is not rocket science. This almost comes naturally to people. But you have an overview kind of KPI, key performance indices of what is going on in an area or a part of, or the overall process. And it might be production rates, might be alarm status. Saw in Toyota's presentation this morning, like a grid of every plant and every different session. They have green, orange, red. So you can tell what's going on. So this is your overall hierarchy of things. You can click on that and get more detail on it. So you go down into the next level. So you get this next level of view of what's happening more detailed on a machine or sub-process level, and then you get down into the details. Maybe it's alarm page, maybe it's actual I/O, right down to every single I/O point. So we got our bulk of our I/O is at the lowest level. Now, I know the tendency for operators, and I don't necessarily disagree with it, but I've seen I/O or graphic pages that have 100, 200, 300 different data points on one page. Operators, sometimes that's legitimate. People like to be able to just glance at it and see what's going on. Other times it's really they just don't want to lift their finger and change pages. Or trust the alarm system that's going to give you the right information. Part of the solution to that is perhaps just considering putting 3 monitors. It doesn't have to be 3, but I'd say 3 is a reasonable idea. On one VTS application, you can put any number of monitors, horizontal, vertical, whatever way you want to run them. So think about an overview page that shows you the overall status, an alarm page that shows you what's going on, perhaps some plots or some detail pages of the process you're most interested in. So you have these 3 up there all the time, and you can just walk by and see what's going on. It's great. The charts, plots, that's a really powerful tool, actually. I've seen lots of utilities take advantage of having just multiple plot screens up. It tells them not only what the status is generally now, but where things have trended over the past day or so. So their main screens are just, 8 plot screens all up on the wall. And the operators don't use those, they can see what's going on. And that gives them, I can see 100 parameters, and I can see how they've trended over the last 24 hours. I don't have to touch anything, I can just glance, and I can tell just from my experience if that's good or bad. Now we're getting down and deeper. Now what happens when you get a big system? Big systems tend to be the ones that start driving performance. So one of the things you can do, especially if you're dealing with a Modbus type or other similar kinds of drivers, is the protocol for Modbus, and the other similar kind of pole response kind of drivers, is that if you read one register and you read another register, if they're consecutive, you can read them at one time. So you tend to try to say, let's keep all my registers the same. You've seen well-meaning PLC programmers that will have registers scattered all over the place. What that means is you have to perhaps read 100 reads on the PLC to get your data rather than 2 or 3. That can make a huge impact on how fast you can get your data. So just a tip is say, keep your data in a compact. You can keep all your analogs in a row, all your digitals in a row. Even stuff in the same process area can be in one block. But keep them more contiguous as much as you can. That'll improve your overall I/O performance. If you're starting to run into performance issues, you can actually say, I should probably throttle back my update rate. Do I really need to see the data every second? It's a lake level. It's a tank level. It doesn't change that often. If you kind of throttle it back, you can make a huge difference on the load on the system. If you need that performance, it's an easy number to do. Just, I can settle for 5 seconds. It's okay. 5 seconds is only 20% of the load of 1 second. It doesn't seem like it's a big difference, but it can make a huge difference. The whole model of VTScada is it reacts to changes. It doesn't depend on how many I/O you have. It's how often the changes come in. And if you're reading in changes, it'll react to changes in the value that are significant. So if you're pulling them less often, because they're not changed very often, or there's a little electrical noise on the signal, you want to use this I/O deadbanding or historian deadbanding. That means that those changes will basically be ignored as being insignificant. So it might be 1/100% change is not significant. So if you do that, you stop the data from being logged in the historian, eating up disk space. It doesn't go across the network, doesn't redraw the stuff on the screen. It's a very effective way of producing unwanted or reducing unwanted CPU load. And again, these are only things you get into when you get into a big system that's starts to feel performance bound. I alluded to this earlier about tags with expressions in the parameters. This really doesn't affect you very much unless you're actually at startup time. And they can be used quite effectively, so I take this with a grain of salt. Unnecessary is the key word here. Minimize the use of expressions for tag parameters. Sometimes they get used a little frivolously, but use them wisely. They're a powerful tool, but if you put them in every parameter, you can make your startup time perhaps 10 times longer than it should be. There's two types of parameter expressions. Ones that get calculated just at startup time, and ones that will, anytime that condition changes, that tag will change parameters. The latter is pretty powerful, but if you don't need that, leave the optimize button on, because it'll only calculate it once. It'll stop lots of redundant calculations, reduce the memory load to have to watch for that data to change. So another thing that optimize, so don't uncheck the optimize button unless you have a good reason to. Now there are good reasons, but if you do that systematically, you can cause some performance issues. And if you're really getting into a lot of heavier load, VTScada quite conveniently allows you to add more servers. So you can share the load across any number of servers, not just two. So if you want to do some load sharing, it's very convenient to just say, I'm going to add another server. I'm going to put all the I/O for that PLC or that subsection of a PLC on that server. The other server is going to take the other half the load, and they'll act as backups for each other. So if one of them is taken down, you'll still poll everything. So while both are running, I can double my performance. If one of them drops off, fine. And it doesn't have to be two. City of Houston's running 4 I/O servers on 125 PLCs. If they lose any one PLC or any one VTScada I/O server, take it down for an upgrade, the other 3 will take the load and divide it evenly among them. So you lose 25% of capacity, but basically you're already running at 50% of what you can do, so you're still running with excess capacity. Servers. Normally 2 is a great idea, not just for the load sharing, but also for the robustness piece of the equation. You don't want some hard disk failure to take you down for an extended period of time. Poor David over here had a hard drive failure earlier in the week during SCADA Fest. Come on, we don't need to have that happen. And he's not even, production. If you're running a plant and you have a hardware failure, you don't want that to happen. Where are you going to find it? You're going to pull a PC out of someone's office. You're going to get one, go to the nearest store and buy one, reinstall, get the whole system up and running again. VTScada is particularly good at doing the hot backup. So if you have a hot backup system, you're pretty safe. If something goes down, there is this case that have this common mode failure. You have a flood, a fire, a lightning strike, where you might want to say, well, 2 is not enough. I need a disaster recovery center that is miles away. In Southern California, we have one customer says, yeah, we have to have a disaster recovery center. Although we have servers here and redundancy in the plant, we may get an earthquake or a fire that the plant is not affected. All the stuff is running. We need to keep the water plant running because if there's a fire, we need water. But we have to evacuate because there might be a fire or a tsunami coming. So yes, we need an off-site place that might be 20 miles away. So there are lots of good cases for saying 2 is not necessarily enough. The Houston scenario of I need more load balancing. I've got 100 MGD plant to run. This one on the server list, we have this concept in the I/O tags where we have named server lists. It makes it easy to manage many PLCs. So if you have a system that has many, many PLCs, and they all want to follow a similar path of, I want this group to follow on one server and that group to follow on another server, we have the idea of having a named server list so that instead of saying I have to individually each PLC say where its server is, I can group them together with this named server list, and you can assign that to the driver itself. That is a great tool to use to minimize the management of, say, 125 PLCs. So the last part of this clause is the important part. Split drivers between servers. There are times when you have a radio telemetry system where all of the traffic has to go through one radio. If you had two radios talking at the same time, they're on the same frequency, they interfere with each other. You're kind of stuck with that one. But most of the time, that's not the way the world works anymore. The world is running on a network, an Ethernet kind of system. So it's easy to say, I'm going to take half my PLCs, put them over there, half my PLCs, put them over there, and that's the way I'm going to run it to load balance. So except in the cases of the shared telemetry path, balance them. Also, when you get into larger systems, I would just say it's probably best to go split your historians off onto separate servers. You're starting to have to get to pretty big systems now to start to say, I need separate historians. Because the normal VTScada systems can run up and handle history fairly well. We found that I/O servers tend to be the bigger load than the historians. But if you start to put a heavily loaded system and then you put historians on top of that, you can reduce the performance for retrieving history and generating reports. And you do want redundancy on your history. Again, you'd hate to have your machine go down and lose all your history. I'm doing a talk more at 1 o'clock. This describes some more of this, but there's a concept in VTScada called, or at least we call a client of client. So it's the best practice. You can imagine that you have a really wide area system where you might have two plants that are separated by a significant distance, and the network connection between those two is not 100 megabits. It might be 1, maybe it's 100K. The network is kind of challenged between those two plants. So the idea is that I really want one machine to be the backup server for the main server, but all the other servers or clients at that remote plant use this one connection point as my gateway for all the I/O. So we have the ability to basically do a funnel all the data through this one machine, and then all the local machines get it from that. So instead of having half a dozen computers going through this one slow link, you have one of them going through the slow link, and everything else goes from there. This is a client-of-client scenario. But if you lose that gateway, no problem. Backup can take over and perform that role. Security. I had this on our front, but hate to start on a negative note. So ransomware is still out there. These are the people that are just extortionists. They are out there to get your money. They're going to, blackmail you into trying to get money out of you, and they're going to go after enterprises that have money versus individuals more so. And the more critical your assets and your operation, the more vulnerable you are. What's even more scary is that cyber warfare is now a real thing. And in that vein, foreign adversaries are really out to get at critical infrastructure. And Dragos, who was supposed to talk at one of these sessions, not this one, but over this next 2 days, they had two guys had to bail on us, unfortunately. They are involved with a operational technology security. And they report that there are been detected lying latent in utilities, power companies and others, cyber weapons, you might say, that are there to be deployed at someone's whim. And these are very sophisticated systems that are not there to do us any good, not to extract money out of us, but effectively bomb the plant, shut you down, take you out of business for as long as they can, to disrupt the economy and the general health. And they may not do it, broad across the board. They may just pick one at a time and knock you down. So it's a very scary world. So what do you do? Get another job. I don't know. This is we're in a very there's fun things to do in what we do, but everything we do is pretty critical. So let's take a few things that we can do to get at things. One of the things that we find that the ways that are mostly the bad actors get into these utilities is through fairly, we call social engineering kind of activities. So I don't want to get into a whole network security kind of thing, but the idea is that people with shared user access. Now, we've heard of a utility in Florida a couple of years ago that had someone operating the system remotely. It seems to have come down to they had all their operators using the same username and password. And they had, somebody came in that was fired, I think, and just operated the system and tried to overdose the chemical dosings in the system. It seems like, that's maybe convenient, but it's not, it's an easy thing to fix up. One of the better ways you can do it in VTScada is to get everybody a Windows domain account and use the domain security attached to VTScada. So when they leave the company, there's one place you take that user off, and it's off on VTScada as well. So you don't have to go around and take them off the alarm system, take them off the accounting system, take them off the door access, take them off, forgot them off the SCADA system. Well, that's not so good. Make use of roles. So one of the principles is that you limit the scope of someone's ability to do things to the minimum that they should be allowed to do. So you don't just give everybody blanket control over everything. That's an Active Directory integration. So if you're going to have remote access for VTScada, you have what we call a VIC server, VTS Internet Client Server. One of the ways you handle that is you put it in a secure environment. We have this ability to go create if you want to, a run-only system. So you can make a system that you can access, but you cannot control from that system, even if you're sitting in front of it. So you connect in remotely. You may be able to view, look at alarms, can't acknowledge anything, but it's a view only. If you need control remotely, you can allow control remotely. But you still have this DMZ ability so that maybe you don't allow configuration on that machine. If that machine gets infected, it's just limited to that machine. It's not getting into your network. So it's a good style of handling your security. And all of your network access should be secured. Whether you use a VPN link or directly into VTScada, you need certificates, and certificates are a pain. They're really a mess to set up. But they're important to make sure you have secure access into your system if you're going to do remote access. And remote access is extremely valuable. So we want to restrict your access. One other thing that we've kind of adopted in the sessions here as much as we can is we don't exchange USB keys very much, because that's one common way that viruses get exchanged is by handing somebody a USB key or picking up a USB key in the floor. I don't really know if you remember, but there was this Iranian nuclear program that was affected by this Stuxnet virus. And the way that seems to have gotten in was through a system integrator who probably picked up a USB key in the parking lot, plugged it into their PC, and that allowed them to infect the plant production system because the whole plant was air-gapped. It was not connected to the internet. But that still didn't protect them. We know that some of our customers will go as far as putting epoxy in the USB slots to make sure that nobody plugs in a USB key into their power plant. It's a bit drastic, but yeah, our policy here in this show is that if we're going to hand you a USB key, we'll take it right out of the box new. We'll give it to you. It's now yours. We don't want it back again. You shouldn't share it with your neighbor either way, because we want if there's any viruses around, we don't want to share them. It's like COVID. You know, sharing stuff around is not a good thing in this environment. It's a real killjoy, this security stuff. I always think that if everybody was nice, we wouldn't need insurance, we wouldn't need police, we wouldn't have all these cybersecurity. We would save a fortune in security. The whole padlock business would be broken down. And this seems a little bit redundant, but physical access is kind of important. Especially in unmanned facilities. If you get something that, you're going to lock your facilities, but it's surprising how easy it is to climb a fence and pry open a lock. So you really have to have some sort of security. Cameras are good, alarms on doors are good. The idea that if someone can get into that facility, they can probably get on the network in that facility. They can operate the equipment in that facility. It's a weak point. So physical security, and sometimes when you're in a facility, you can walk in. It's not that hard to walk into a control room sometimes. So it's just, a tough world. Let's get on to the fun stuff, computers. Hardware. Hardware is a good thing. And size matters. Again, when you're starting to have performance problems, that's into the many thousands of tags kind of issues generally, you think about machines that you're going to purchase, and this is a common mistake that a lot of IT customers tend to make, is they go after, I want the best server. And what that really means to them is a very slow machine that has many, many, many cores and lots of RAM, big disk drives. That doesn't get you there. Think about something that is really a gaming machine, sounds bad, but is an engineering workstation kind of machine that is designed to run one task really fast versus a lot of tasks. So that's what you're looking at. You're looking at engineering workstations as your target if you want performance. Go for high clock speeds. The new machines are up to 6 gigahertz in clock speeds. We need some cores, but don't go for something with 64 cores. It's not going to get you there. Go for the ones that, if you have 8 cores, you're probably gold, and you're going to get as much as you're going to get out of. Because running one task, we're running one program. The 12th to 14th generation Intel i7, i9 processors are where you want to go. So don't go. I've seen people try to run on a Celeron processor or even an i3. Sometimes you can do it if it's a really small process, but we're running mission critical stuff. You don't want to mess around with that, because that will just frustrate operators, get overloaded, maybe reduce the response time for alarms. 16 gigabytes of RAM minimum, that's just a benchmark. There are some systems you can run with 4 or 8, but again, we're talking about the bigger system when size matters. Go with 16. This laptop here is 64 gigs. It's not a big deal anymore. Solid state drives, don't even think about spinning rust. Spinning drives, not worth it. Less reliable, much, much slower. This will get your history up faster, start your applications faster, generally a much better solution. RAID's not necessary, although possible. We have redundancy across multiple computers, so having redundancy in your hard drives, it's okay, but it doesn't gain you a whole lot. VTScada's redundancy just carries that redundancy across a separate computer, not just the hard drive. On some panel PCs and others, you get this idea of a motherboard type of video processor, and that's sometimes I've seen that on server type machines that are never intended to have a display, but they do have support for the display. But the display support on those is so slow that it actually eats up most of your processing time just drawing a few things that are changing on the screen. So you wouldn't think that the graphic card would have much of a difference, but we have seen times where you can get 30% of the CPU being eaten up by just redrawing graphics on a slow video card. So you can make you can sort of like get a 50% boost in your overall performance by getting a decent, not a killer, but a decent video card. You don't have to get a AI type generator video card or a gaming type video card, but just don't go with the very basic ones. So, questions? Sure.
On the tag top template, does that, like, how would you do that between projects?
The tag templates?
Yeah. So, like, for instance, kind of what's in my head, like Alan Bradley has, you know, plant packs. If you're doing the plant packs and you're trying to do multiple projects using that, how would you pull that across projects?
Right, so I didn't touch on it, but there's it's a really good point. We have this capability called an OEM layer, called Original Equipment Manufacturer. That's where it kind of shoot at that type of market. So the OEM layer is basically like another application where you put all your common tools that you intend to reuse across projects. So it comes into facilities where I want several applications, one for plant 1, one for plant 2, and I just want to keep them separate, but there's some common tools I want to use. Or your system integrator, and I have these same kind of projects that keep coming up. I'm going to put my common widgets, tag templates, and other types of common things that I want to build. I put them in this OEM layer. And you can upgrade that OEM layer across all projects without reworking any of that type or any of your projects. You just update the one OEM layer that's common. So it's like another piece of code or another application layer that goes in between the core VTScada and your application. So when you do that, you don't have to you can change each layer independently of the others. You can change the version of VTScada and the application without changing your OEM layer or any of those things. So good question.
So if you do that, if you use the OEM layer, you can pull the template and create the regular tags in your application?
Right, the template will just automatically appear in your application. You don't have to actually import it or anything of that sort. It's just going to be there.
So you don't have to go to the OEM to make the changes to the template or anything? Or?
You will if you have to go into, if you actually want to make changes to your template, you go into the OEM layer because it's going to be common to everything. But you could override it in your application layer specifically for that one application.
All right, thank you.
Yeah.
Great question.
If you've got, hold on. Big room. He had a good voice, though.
So if you've got thick clients in your system and you upgrade your servers, can you connect a version 8 to a version 12 server? So like if you've got another thick client, will they still interact, or do you immediately have to update that thick client as well?
So there are some significant, some major version upgrades where you have to read the construction. There are orders in which you'd upgrade, but we've always supported upgrading one at a time with days in between upgrading the other. Mm-hmm. So we always support not having to shut everything down and start everything back up again with everything new. So you can always systematically upgrade your things. Sometimes it's going to be upgrade the server first, sometimes it's going to be upgrade the client first. But in all cases, there's a way to upgrade one machine at a time, bringing them all up, and they don't all have to be done the same day. Yep, it's supported.
Okay.
Anyone else? Oh.
When doing your tags, is it efficient to pack Booleans into an integer for the reads and then unpack them with an expression in VTScada calculation tag?
I'm sorry, I didn't quite catch that.
Like when you have a bunch of Booleans in your PLC,
yes,
is it more efficient to pack those into an integer to have VTScada read and then unpack those using an expression in VTScada like the bit command? So you can get away from the contiguous, have more contiguous, aside from the contiguous read addressing.
Right, so you can, if you had a Modbus register that had 16 digitals in that register, I would still read the digitals one register at a time, because that's more efficient, because if you had the former, any one digital changing would cause the calculations to re-trigger, and that's more costly versus reading each one of them and only one bit changes and only that one changes. There's no calculation required, it just passes through. So yeah, it doesn't take any more time to read if they're unpacked on the server, or you just read it naturally. Yeah. Another question right up here.
Going back to OEM layers, is it a better practice to just distribute those with snapshots instead of installing the OEM layer as it is on the client machine?
Yeah, so that's a good question. It depends on your philosophy. My general philosophy is that if you you give the natural change set to your customers, they can see all your revision history. Now, you may or may not want them to see every change you've made all along the way. Snapshot will avoid that happening. If you're protective of your intellectual property, you can create what we call a run-only snapshot, which only doesn't show any of the source code of how the system is built. It allows them to run it and use it, but they can't view it or edit it. So that's the snapshot run-only change set. So that's what we would tend to do, is say, I don't want anybody messing with it. That's going to be, I like to know that that is what it is and somebody else isn't changing it along the way.
Yeah, we've run into a problem where we go to a place, install the OEM with the project with it, then we come back and pull the project off thinking the OEM layer is not changed, and then we get an error when we try to load it on our integration machine saying OEM layer is different.
Yeah, so it can depend if you want to allow the customer to build and edit that and maintain it, which is still quite legitimate, but you just have to be aware of that. So if you want to be, the sole controller of that layer, then the snapshot run-only is probably your best bet. Lots of questions today. This is great.
On several of your slides, you mentioned a large system. What is your general characterizations of a large system?
Well, it's not so much I/O tags, but they tend to be related. So a large system is going to be something that I would consider as changing, perhaps. Number of tags changing per second is going to be 5,000 changes per second. Now, you can have a 100,000 tag system which changes only 100 tags per second. Or you could have a 5,000 tag system that changes 5,000 tags a second. So that's the real load on the system. So generally, I would say if you're getting into a larger system, you're probably north of 25,000 tags.
Anyone else? All right, well, that wraps it up. Thank you, Glenn. That was great.
Yeah, I know. It's nice to actually have a little more time. We've got till 2:30 for the next session, so enjoy yourselves. Have a nice day. Thanks for coming. I appreciate the full room.